I got it.
Great. And with that, I think we're probably ready to start since it's now 5 after. Yeah, howdy people who are interested in some team and project management. So we're gonna do this one sort of broken out into a couple different sections where we're all gonna talk about different things. In case you don't know who we are, I lead the NASA team. I'm Robert. Peter.
I'm Jack. I'm the club president.
I'm Peter. I attempt to lead ROV.
Sweet. Let's actually work. Yeah, so first thing is really general idea of why team and project management matters. Obviously, it's something that's talked about constantly, and whether you have a good or bad team, or whether your project is successful or unsuccessful. And really, even if you don't actually see yourself managing or leading a project, knowing sort of the process of that project management helps you be a stronger member within a group. And leadership and management has a bunch of different terms and buzzwords and things. And ideally, what we're going to be trying to do today is get a little bit of that clear with everyone, and make some of those terms a little bit easier to understand, or give them in a way that doesn't bog through all of those terms. I think Peter's going to start with design team leadership.
Yeah, that'll be me. So I'm here to talk to you all a little bit about design team leadership. Before we begin, for some of you who don't know me, you can be saying like, why am I qualified? I'm not really, but I've had experience leading electrical design for ROV and now overall team design for ROV as well. So ultimately, you have to first boil down what a project is. And every project starts with a problem to solve, or hopefully you're trying to reach some goal. The problem could be a little more abstract. But in our case, we have some problems such as, this robot needs to dig on Mars in the case of NASA RMC. Or an ROV, I don't want to get water in my electronics, which is a problem we fail on yearly, but we still try and succeed anyway. Or the problems could be as outlandish as this cat is eating my socks. I don't want that. Or Honey Nut Cheerios is catching on fire and burning down my warehouse. And for the dreamers out there, maybe one day you want to go to the moon. So all projects start with a problem to solve, and defining that problem is the first step in any great project. Next slide. So first, once you've defined your project or your problem that you're trying to solve, you first need to set some requirements. So these, look different for each project, but generally there's, you define your project requirements based on the constraints you're looking at. So you want to go to the moon, which is a great problem to solve, but you have a budget you're trying to meet, deadlines you need, certain deliverables by, and then physical design constraints such as size and weight, or in like electronics, current and voltage requirements. So you need to take these requirements and then begin to boil down your project and set forth kind of the goals you want and how you plan to meet each of those requirements. Next slide. So in general, there's kind of a brief structure that most projects follow, or most successful projects follow. You first, it doesn't have to be written, but you first start by setting your problem and then looking at your criteria and constraints and setting your goals and requirements. So what does our system need to do? What would our perfect solution to this problem do? And how does it meet these physical design constraints as well? And then you get into a phase where you're just brainstorming. So you draw some sketches, you do some preliminary flow diagrams. For electronics, you would start out with like some block diagrams or state machines. Block diagrams are a great way to start, honestly, just blocking out what your system needs to do on a high level, kind of a level 2 evaluation. And then you look at these concepts, because that's all they are concepts. And also never rule out any of these concepts before you review them as like a team. So take all these ideas, and from there you can kind of chip away and see what you like, how the blocks best fit together, and how the easiest path to get to your desired goal. So then you start the detailed design, and you break out in, for robotics speak, we break out into mechanical, electrical, and software, the three main divisions. But this could look different for different projects. It could be a firmware and hardware team if it's a solely electrical team or a solely electrical project. So you start to get into the design, and the design really takes the most time. And then you go through a critical review. You've whittled down all these brainstormed ideas, some of them good, some of them not so good, and you focused on your one design that you're working on. And then from there, you do a critical review. Am I being as efficient with my design as possible? Is this the best way to do it? The little idiosyncrasies, prototyping, testing, making sure everything works together in conjunction. And then from there, you build it, you test it, and if you're in a consumer setting, you profit. Next slide. So you have three key project elements, and these three, kind of make up a triangle, but they're always fighting each other. You've got time, resources, and scope. And what I mean by they're always fighting each other, and I'll get into this a little bit more on the next slide, but if you need more time, your resources may be less if your resource is money, because it costs more to get things done quicker. If your scope increases, your time budget will go down for each part of the project, and you'll have to reallocate resources as well. So these three kind of work in harmony together. Time is obvious of what it means, resource is obvious, but next slide we'll get into scope. So scope is kind of like what you're trying to do with the project. It's everything your project encompasses. So for ROV, it's having a mechanical system that is able to perform all the tasks, an electrical system that enables these tasks, as well as enabling control, and then software being able to do the tasks from a surface computer, as well as the autonomy tasks. So that would be our whole project scope. And as you go through a project, the scope may increase or decrease. You may be able to say, I don't think we need to do this. This isn't critical, and cut that from your scope. Or you may get halfway down through your project and start realizing you need to add on or do more, or there's something else you need to add. I know for speaking from personal example, this happens a lot with electrical design in general, because you get deep into doing schematics or circuit design, and you start thinking of features you can add. And sure, it only adds a few dollars here and there, or like an extra few hours of work initially, but these things all add up. And so you really need to watch out for scope creep, where you start to add to the project. And this isn't usually a problem, but you need to have good management to adjust for it. Sure, I can add an extra, current limiting circuit on a buck converter. But to do that, that's an extra hour or two of design work that I'm not spending on control electronics. Sure, I can add extra manipulators, but that requires extra resources in the form of materials. So you have to really be vigilant and keep track of what you're adding to a project to make sure you still reach your goals. Because as I mentioned, your time, resources, and scope are always competing to stay in balance. Go ahead for the next slide. All right, why projects fail. Personally, I've been on several project teams throughout my life. Most of them have been pretty successful, but we've certainly had our failures. The biggest one I see is poor time management. A direct quote, but really a paraphrase. It's fine. We can make everything in a hotel bathroom the night before competition. Real true story, as evidenced by this picture. But yeah, you want to stay on top of your time management. And I think time management is one of the first to be lost. And I think it's one of the most common problems, because especially as leaders, it's easier to drive your team harder than they're willing to go. It's easy to get so invested in your project as a lead that you realize, or you lose sight of the fact that your team members have other things going on in their lives and can't always meet the schedule you set forth for your project. So you need to make sure that in your scheduling and your time management, that you leave room for both extending timeline and also little air gaps where if a team member can't get something done right on time, it's okay. The last thing you want though is push it to the very end and the night before competition, you're soldering in a bathtub. The other reason is dwindling membership. As I'll talk about in a slide or two, ultimately what makes a project successful or not, regardless of all that we'll talk about today with documentation and design phases and whatnot, it's the people. Without a good team, you're not going to be able to succeed. That's just my personal opinion. And if you start losing members, your project is going to be a lot harder to accomplish and be successful in. And the biggest reason you lose members is people feel unvalued, they feel lost, or they just don't feel like they're needed. If people don't have a reason or a purpose in showing up to your meetings or to participate in your project, you're going to lose that member. And I think this is something that robotics as a whole has done really well with in recent years to improve membership retention. But especially in the world of Zoom, it's really hard to do. And it's something, I personally struggle with, is making sure everyone feels valued and everyone has a clear view of what they're doing and what they're working on, and that they are an important part of the project. And it's hard to communicate sometimes when we're all just staring at screens all day with little human interaction. But it's definitely something that we need to focus on. I think personally, the people and the relationships on a project team are more indicative of the team's success than anything. I think if you have a good working team, you can overcome any problem. Again, scope creep without correction, adding too much to the project without properly allocating time and resources to them, because then they lead to other problems like lack of money or lack of funding, lack of time. They really cause issues down the line. So you really need to make sure you're keeping up with your scope creep and also correcting where need be. It's okay to, change the scope of the project, but you just got to be vigilant of it and make sure you're on top of it. And again, lack of resources, not budgeting properly. For those who have worked with me, both treasurer and ROV, know I've been neurotic about funding, just so we make sure that we have enough to build exactly the robot we want. Because I don't want to get into a situation like our first year where team members are being asked to shell out of their own pockets to finish the ROV. And that goes for any project. You want to make sure that you've got the proper resources allocated exactly where they need to be. And then poor requirements gathering. If you don't know where you're headed or what you're trying to do, you're not going to be successful. You need to know exactly what you're doing and where you're trying to go. All right, next slide. All right, this is kind of actually Reese, our former lead, made this, but this is how he defined the project management lifecycle, and I largely agree. But it's 10 simple steps to kind of rely on as standards. So first you define the project. So this is, what is your problem? What are you trying to achieve? And then from there you generate tasks. You assign your different team members to different tasks to break up the work and kind of break down the project in small manageable steps that you can achieve on a weekly basis. Then you determine roles and responsibilities and develop time estimates. And the estimates in general, estimates for cost, estimates for schedule, how long you think things will, different tasks will take. Define interdependencies and analyze the critical path. Basically, there's an order of operations to project management. You can't assemble the robot before you design the robot. You need to have a clear path to your end goal and set it up. So preliminary design leads into critical design, leads into manufacturing, that kind of thing. Then you develop your schedule. So kind of break out your whole timeline into those individual tasks. And you perform resource loading and leveling. Make sure you have enough resources to complete the project, and then reevaluate as you go through the project. So you don't make a schedule in August and then COVID happens and you have to still work on that schedule in August pre-COVID. You need to reevaluate your schedule constantly, make sure everything's staying on track, and make sure your project timeline is realistic as life happens. Then you generate a project budget with allocation for each individual, in the case of robotics sub-team. So you allocate, $1,000 for mechanical or $2,000 for software, what have you. Then develop a risk management plan, your contingencies, your backup. Make sure that all your risks are managed. Anything that can go wrong is accounted for. Tracking the manage the project as you go on. A project is a living, breathing thing. You got to kind of grow with it and see how it's growing with you. And then once the project's done, wrap up and get feedback. In electronics, the big thing is you always want feedback. It's a great way for regulation. And the same thing goes for project. You always want to be checking in and seeing what you can learn, because each project is a learning experience. I know that was a big thing after our first year in ROB, is we had a great talk about what we could do better and where we can improve. And it's definitely helped as we've grown as a team. All right, next slide. All right, the slide no one really wants to talk about, but we need to, and the bane of every project manager's existence: documentation. Documentation is a bear, because at the end of the day, it feels like busy work. You're making a document that, not a ton of people are gonna find super valuable, but it's really important for the success of a project. Like Reese said, it's always an effort to maintain, but it really can make or break the difference in a project's success. You need to use it. It's more than just creating the document. You need to use it for what its purpose. If you make a Gantt chart, you should reference it and update it to make sure that your scheduling is staying on track and what it should be. If you make a work breakdown structure, you need to make sure the people delegated to individual tasks are sticking on task. If you make a Pew chart, make sure you use it for understanding the risks and rewards and weight of the individual tasks you're evaluating. So you're always trying to accomplish something with these documents. And if you're not trying to accomplish something with the document's kind of pointless. And then also keeping up on documentation is really important, because in May, you won't remember, oh, what did we do in October? Like for software, why did we write this section of code? What does this do? So you just want to keep up on your documentation. And there's a link there. We won't go through it, but there's a link there for some templates of core documents, such as Gantt charts and work breakdown structures. All right, final slide. So just a final note, and these are just kind of my thoughts on design team leadership. As I mentioned earlier, ultimately, design team members make the team go. As much as the leader may, push and pull, ultimately it's the individual team members that make the team go. And your job as the design team leader is to find your ways to use your members' creativity and skills to benefit the project. But don't lose sight of the purpose of the team. While we're here to build some really cool robots, we're also here to be educators, mentors, and students. We're here to learn, we're here to have fun, or here to grow as a team. And I personally believe you can't be an effective design team leader without understanding the people on your team. You kind of need to know where their head's at, what their strengths and weaknesses are, understand even granularly their weekly schedule, how busy they are, to understand how to make your timelines. Like exam time, I usually shut down some design work or expectations, just so students and team members don't feel too stressed. And as I mentioned kind of throughout it, all these guides and steps are just a means to facilitate the function of the team, but they serve as standards to fall back on. But ultimately, you just kind of need to get in touch with your team, see where they're at, and then use these standards to help facilitate their growth and their success. It's more individualized than a cut and dry, you fill out these charts, your team's going to be successful. You kind of need to take the temperature of your team, and every team's different, and see what works for them. Check in frequently, always be getting feedback, both because it makes you more approachable as a leader, and that way you can provide the best for your team. And then finally, listen. Ultimately, you got selected for your leadership position by your team members. It is your responsibility to succeed in that role and, fulfill the promise and responsibilities that you gave them when they elected you. And they have brilliant ideas. Often they're better at doing the work than you are. So just listen to your team. Everyone's valued, and make sure everyone's in it together, and that will lead you pretty well to success in your project. With that, my slides are over. I'm not sure if we're saving questions for the end or now, but if anyone has a question, I'd be happy to answer. Otherwise, Robert, you have the floor.
Yeah, I think first, thanks, Peter. And again, yeah, I think if people have questions on any of that now may be a good time before we get into the next part. But if no one has any questions, so I'm going to talk about systems engineering, which is sort of the more technical kind of form of what Peter was going through. You'll see a lot of similarities between what he was saying and what I'll have here. There's just slightly different words and terms. This is also all, I'll say now, mostly focused around how NASA has put together, or NASA as a whole has put together systems engineering through some of their systems engineering documents, as well as how our RMC team has put together our systems engineering documents based off of that. So systems engineering is this methodological, multidisciplinary approach for the design, realization, technical management, operations, and retirement of a system, which is basically just how the project is led from the beginning to the end, and really includes the technical and some of the non-technical members of the project. The overall goals of systems engineering is to listen to what the customer or stakeholders want, take what they want, decide what needs to be done and what we want to be done. That's always an important thing, because figuring out which things really need done versus what really you want to be done ends up giving a better idea of avoiding, as Peter said, that scope creep, because we know things that we want that may help, but if that doesn't necessarily give the success to the project, then it doesn't matter if you've done all the wants. You need to do all of the needs. You also talk about the documentation of what you're doing and how it relates to what you need to do, and really work on trying to make these needs and wants a reality, and trying to get as much of both of them, really all of the needs and as much of the wants as possible during the project lifecycle. So the basic design process for systems engineering, you'll see, is very similar to the few steps that we had before. So you've got your concept and trade studies in that phase A, or pre-phase A. Then you have concept technology and development, as well as your initial design, detailed design, building and assembly, testing, and then operations and closeout. We'll really focus on those ones in bold there, so that A through D in this part of the presentation. So phase A is that concept and technology development, where you're trying to determine the components of the system and how they'll solve your requirements. It typically ends in a system requirements and definitions review, which is basically you going through with your customers or stakeholders and, in the technical side of things, trying to explain to them what you thought they deemed most important. And having that communication allows you to ensure that from the beginning, you know that your requirements fit what they want. And in this time is when you get a lot of your initial sort of documents formed out, like your work breakdown structure, your concept of operations, and other documents alongside that. I guess also that's a good point where you'd probably have your Gantt chart, or maybe even in that pre-phase A. But in phase B, you start to get into that preliminary design and technology completion. And so that's where, as Peter said, you're basically starting to brainstorm different solutions to your problem. So once you've passed your systems requirement review, and both the engineering team and the customers all agree that what you started with is a good basis, then you start to go into that brainstorming design, and it'll typically end with a preliminary design review. So it's your first design review showing off your idea for your project. You may have, depending on the size and scale of the project, individual PDRs, though with the projects that we do on this team, we typically only have one PDR. And at this point, you'll start to have basic CAD, you'll have basic requirements for your verification and validation plans, which are basically your plans for testing the system throughout the project. And one thing to note is that verification is basically that you have shown that your system meets its requirements. So for example, on the NASA team, we have a requirement of we're supposed to weigh within this amount or have a mass of this amount, and it's 60 kilograms. And so we can verify that we are within 60 kilograms by weighing ourselves, or I guess technically massing ourselves, but weighing ourselves. And validation is making sure that the system that you've done actually meets the requirements that the stakeholder has. And so really that difference between those is kind of niche depending on how well your requirements fit. And so the idea that validation is you could fit all of your requirements and make it perfect, but that doesn't necessarily mean that the project is up to spec to what the customer wants. And in that case, you still failed. Obviously, a failing project can fail in a bunch of different ways. And not every failure is necessarily detrimental to the whole project, but making sure that you have that validation plan that fits what the customer wants is very important to make sure that what you're going through in your design is important. The last one here is the technical performance measures. So as Peter said, you want to make sure that you're paying attention to everything going on in your project throughout the entire time that you're looking at it. So this is one method that you can use to be able to do that. Basically just looking at some of the requirements that you have and how you can end up measuring them with real empirical data to make sure that you're following within your requirements. But once you've passed that preliminary design review, you start to go into your final design. So it's now you've got your approved idea for your project and you can start to go and actually finish the design of it. In this completed design, you're really making sure that you know every single thing that you're either going to make, reuse from some other project, or buy for this project to be able to actually build the system. So this is where you get on, say, the mechanical side, that nuts and bolts level CAD, where you're really making sure that you have accountability for everything. And this typically ends in a critical design review. Again, lower subsystems may have individual critical design reviews, which again, with the size and scale of our projects, we don't do too much of. I know on the NASA team, we'll sometimes have a separate review where we look at some of the mechanical stuff, but it's still mostly all done in a single design review. And the documents really included in this one is just the things that actually show that the robot design or the system design, whatever it is up to snuff and actually fits everything needed for a final design before you can get into that phase C2, where you actually start to build the thing. And at that point, you really start to build whatever is needed to put the thing together, as well as assemble everything. So at the end of C2, you have your system actually completed. This typically starts with, depending on the section, a production readiness review. So on the NASA team, we'll also call them the release for manufacture, where essentially we just look over anything that needs to be built physically. We look over with a fine-tooth comb one more time just to make sure that everything is ready to actually be manufactured, and is actually realistic. Because you can come up with a solution that solves your problem, but if you can't make it in real life, then you can't make it in real life. So you want to make sure that you can actually build it, and having that review before you start building is always important in case you do need to change something. And like I said, really documentation on this is a little bit more abstract because you're really actually building the system. You do want to keep in mind that through this, you are keeping up to date with any previous documents that you've made, especially like the technical performance measures where you're actually tracking throughout the process, even with building. Then you go into phase D where you finish putting everything together, and then you actually start to integrate the system and start to test it. And as you're going through testing again, you're looking back at your verification and validation testing plans and making sure that it's actually fitting those. And if it's not, figuring out what you can do to change it. And so you're trying to put everything together just to make sure that it all works and it all fits what you need. Typically, this will end with a system readiness review. With us, we don't really do this quite as much because we're not putting something really out there. Most of our stuff ends in competitions and not a real system going out into the world. So we don't do that quite as much, but it's really important to show that everything fits both the testing and validation before you throw it out into the world, because you could have the thing just not actually work the way that you intended it to once you get it out there. And at that point, it's a little too late. So you want to make sure that you get those reviews ready beforehand and make sure that it actually fits everything that you want before you end up sending it out. Then the last thing that I have here, because I mean, we've gone through a good bit of technical information, and there's a lot of documents that you may or may not need to write. And on the scale of what we do, like I said, there are some of these things that we don't do. And there are projects that if you don't do all of these things, you will guaranteed fail. There are other projects where if you follow this, it's a lot of wasted time. And so really, projects of any size benefit from this process, even if it's a little bit more loosely done. And some documentation may not be as important depending on your project's size. And so you really want to remember that balance between what you're doing, because as Peter said, we're here to have fun and to learn and to build robots, and writing documentation isn't exactly the one that gives the most fun to most people on this team or actually builds our robots. So I could have all the paperwork done, but if the robot's not done, it doesn't matter. We're really trying to build a system in the end and not write documentation. So you want to use this structure in a balance to make sure that you can end up actually getting everything done for your project. And so if there are any questions on that, and if not, it'll be Jack for people management.
All right, I guess we can go on here. So I'm going to cover people management. This is much more about on how you're going to want to run your team and work with people on your team as a leader, and how to create effective teams and help you achieve your goal. So it's not really that technical, or even for explicitly for design teams or system engineering. This is much more broader in scope. Next slide. Actually, before there is a big thing is how you want to run a meeting. Someday along the way, you're going to have to run your own meetings. How are you going to do it? What do you need to bring to the table? And why are they really important? And the reason why you want to do these meetings are important are because this is the point where your team comes together, they can process all this information together, and they can be present and they can collaborate. This is the point where all your different subject matter experts, all your different backgrounds come together and approach a problem. So that's why I want to hold these meetings on a regular basis when you're working on a project, that you can have that input. Next slide. When you're having that meeting, you're going to want an agenda. And agendas are important for two big reasons. One, it keeps track of updates on your project or team. And two, it provides structure to your meetings. One thing is you want to have for first part for keeping track of your teams, you want to always asking 3 big questions on your agenda for during your meetings. And the first question is for all your members should be reviewing what you said you'd do with the previous meeting. And that's going to be basic what you said you do. You say you would go work on designing a PCB board. Asking what did you do in the week since you said that? How far along have you gotten in that? Did you make the PCB board? Did you not? Are you somewhere in the middle? Get that feedback and then ask, what are you going to do before the next meeting? It could be something as sending out that PCB board, or we're going to keep going to it and keeping track of that progress on a week to week. And that's one thing you want to ask, have that on your agenda to remind people, say, we're going to talk about this, and also record what everyone says, as well as also just remind yourself to ask everybody. That's kind of important with the team lead to make sure keeping tabs when everyone's up to. The other important part on the agenda is having your defined action items. You want to have it put in place, what's going to happen during your meeting. And this is important for 2 reasons. First one being that everyone kind of knows what's coming up. So we know what this is going about. It's well established what we'll be discussing, as well as for it keeps meeting on track. It's really easy to get distracted during a meeting. It's really easy to get sidetracked and sometimes harder to come back into the center, talk about what needs to be done. And having that agenda laid out with those defined action items sort of brings it back and keeps you going on your way. So your meeting's done in a reasonable time. I also want to try to get out in advance in case people want to edit it or add notes to it, and that people are aware what the meeting's about, because sometimes you're going to want to have feedback from some of your members. So if I say in the next meeting for an exec board meeting, I want to talk about a budget issue, and I put that out on the issue and I set it out far enough in advance, and people look at it, they know we're having a budget meeting going on. So people will bring stuff on that, and they'll be a little aware of like what we're talking about. Or if we're with, say, when we're design teams and we say we're going to cover what's needed for the next design review, we're going to then, people will come to that information saying, what do I have? What do I need? And people will know what's coming up in advance. Next slide. When having your meetings, you have your agenda. Now the next point is, well, we have to have a meeting, and now we have to, where we're going to have it. And obviously in the Zoom virtual environment, when you're trying to get your environment, what you want to pick is picking regular meeting locations for meetings. You don't want to change them either. You want to make sure that you pick a meeting time that, Ben, something wrong? Did anyone else freeze? My kind of computer kind of just went down for a second.
No, I still hear you and everything. I don't think it froze for me.
Yeah, it didn't freeze for me.
Oh, can you hear me now?
Can you hear us?
Hello?
Can you hear us?
Oh,
Hello?
I'm going to take this as a no.
I'm going to take it as a no. We'll see if he can see the chat next. The glorious wonders of Zoom.
Yeah, quick shout out Zoom University.
Okay, hang on. I found the next slide. Yeah, it was still stuck on the previous slide for me. Okay.
Can
All
you
right.
hear us though?
I can now hear you.
Cool.
Yeah, that internet connection problem. All right. Next slide. Yep. Okay. So tips and tricks for meetings. You want to have your regular meeting location. You want to pick some place where everyone can go, it's accessible. If it's in person, things like whiteboards would be good. It's too big. It's big enough for everybody. That it's not going to be really a distracting environment. It's probably so you don't want to have some place like the middle of outdoors where it could be rainy, hot, cold, or super noisy. For instance, when we're in person classes, when we were in person, we would have meetings in the main lecture hall in Glennon. Now that we're online, one place to make sure it's accessible to everyone has been Zoom. When there's not internet troubles, it works well. But when there is, but the point still being that you want to find mediums and platforms where you can have these meetings where it's regularly accessible to people, and also you don't change it. You want to keep them on the same time, and you want to make sure everyone knows it's a recurring event. When also having these meetings, you want to send out reminders and materials ahead of time so that people know what's coming up. As I said in the previous for your agenda, you want to send earlier. Make sure all materials for that meeting are also sent out ahead of time. If they're having an in-person meeting, you want to bring extra copies of materials in case people show up that you weren't planning on showing up, or there's just more people than anticipated, so you're always prepared. It's usually a good thing to have people read the agenda before the meeting, but in reality, how often does that happen? So usually it's good to find a way to display the agenda so everyone's aware during the meeting what's going on. And while we always try to start on time with our meetings, doesn't always happen, but it's always a good goal. Next slide. Other things for meetings. Other things we want to do is for documentation purposes is going to be taking notes, minutes, and summaries. It's always good to know what you said and what was decided upon a meeting for going back, so you don't have to rehash the same conversations. Other things to note is if this is a meeting needs attendance, it's good to know that you need to note who comes and who arrives late and who doesn't show up at all, so that that's progress you can track. It's also good for working on team collaboration to see who is and isn't contributing. If you just notice that it's the same 3 people in your 10-person team that are talking all the time, then you're kind of leaving people out, and that's leaving people feel excluded. So it's good to notice when that happens and then try to bring them back into the conversation, try to re-engage them. When you're having these meetings, and every so often when things good is to have an evaluation, send out feedback to figure out how meetings can be improved, or how did that meeting go in particular, or is there a way we can restructure these meetings so that we're doing something that actually helps everybody and keeps everyone engaged. As I said earlier, you want to avoid canceling meetings when setting up your meetings and meeting times. You want them recurring, and you want times where everyone can show up, and that creates this constant schedule of getting that nice repetitive nature of your project. One thing I mentioned earlier about when you're taking notice of who does and doesn't show up. If people aren't showing up and they're repeatedly not showing up, it might be good to follow up on that. We don't always do this in robotics. Sometimes maybe we should, but if it's having recurring and even a project where people do need to show up, it's good to follow up on there and provide them information why they didn't show up, or ask why they're not showing up, and just working on feedback to try to bring them back into the fold, keep them engaged. Another thing too is during these meetings is a time when you start to delegate tasks. This is also when you're in this big systems projects and design projects, you obviously can't do stuff alone. So this is when you start giving people up projects and assignments that those people feel comfortable and capable of doing. You want to make that's very important, because if you give someone who's really skilled a really easy project, they're going to get bored, they're going to leave, they're going to want to go do something else. But if you give someone a really difficult project and they're kind of new to it, they may feel overwhelmed and they may also leave the project. And either way, both those tasks don't get done. Next slide. Documentation. I'll just go this real quick because it's kind of brought before. It sucks, but it's really important. Mostly in these meetings, we have meeting minutes to keep track of the big decisions we made, the important topics we discussed, and what's also been postponed. And that also leads into the action items for the next meeting to be discussed next time. It's also when you also want to keep documented all future events, all tasks assigned, and keep track of that on a week-to-week or at least a meeting-to-meeting basis, a better way to put it, a meeting-to-meeting basis. So you know what's happening from the previous meetings and next meeting. And if you need to, you can go back and you can find previous information in case it comes up in discussion. Also, part is communication documentation, whether it's like the emails, Slack, or form submissions to basically get ways to figure out form submissions to get that feedback, or even voting in meetings for those submissions to keep the documentation as well. Next slide. So getting into effective teams and how to create an effective team. There are some more broad goals, things you need to achieve. And those are going to boil down to that your team understands the problem and your team feels comfortable feels comfortable with its own skin, and that they trust each other, that they respect each other, and that they're willing to collaborate and communicate. And also that there is this idea, this feeling of engagement, and you want to be able to replicate that in your team, and in order to be effective. You want to be able to make sure everyone understands what's going on, because if not everyone understands the goals or is even wanting to commit to them, they're not going to be engaged. They're not going to know the whole problem, and they're going to eventually fall off. They're going to eventually want to go away and leave. If the team members don't feel that they can trust each other, or that they can communicate or collaborate or throw out ideas without feeling that you're going to get ridiculed or laughed at, or just disregarded, they're going to become disinterested, and they're also going to leave. If they don't feel like they have an input into the decision-making process and making decisions for your team and project, they're also probably not going to want to be engaged well. So you want to make sure that all your team members, that they feel like they understand what's going on, that they can throw out ideas without feeling the risk of like embarrassment or being insulted, that they feel like they're being engaged in the decision-making process. And you want to keep that, you want to get that balance in there and make sure that your team members stay engaged and you're creating an effective team. Next slide. Team leaders. Each team needs a team leader. Most of those team leaders on a broader scale are mostly for team meetings. They're more responsible for running those team meetings, chairing those meetings. And again, they should be using those practices for agendas and time boxing discussions, where you write your agenda, your action items, and that you sort of block out when conversations happen. Because sometimes your conversation you thought might only take 5 or 10 minutes could take 20 to 30, 40 minutes. And you don't want to run on forever. So putting an end cap on that conversation is good, because you can end the debate and go on to the next topic, and you could save that debate for the next meeting or discussion for the next meeting. And you can keep and write down everything that was discussed so that you can continue to the next time. Other part is guided brainstorming. We're working on a collaborative effort like our design projects are. It's really good to get a lot of good ideas out there. However, you want to kind of reel it in sometimes, where you don't always want to have, because if we're trying to find a problem for, again, as Peter put in ROV, getting water and electronics, it's great to have you want to have people brainstorming, put out new ideas, solve this problem. But you want to keep them on topic for finding a solution for the water, getting electronics, and also providing like feasible solutions, and not like something that's really crazy or insane. Like someone saying we're going to use like an infinity stone, or getting crazy off topic. You want to bring them back and keep them somewhat directed during your meetings. From a day-to-day level, team leaders are more responsible for just keeping track of your accomplishments and goals of the team. We do through Gantt charts, and to make sure that we are making our deadlines, as well as for our project as we go and near the end date. Also, as part of team lead, you're responsible for helping team members develop their skills. When you're presenting people with new challenges, they're going to be faced for projects. They will need to learn stuff. They may need help and assistance with the project they've been assigned or assignment they've been given. And you're responsible for helping provide the tools necessary to develop those skills, whether it's helping them yourself or connecting them with someone that already knows how to solve the problem. Maybe someone on the faculty, maybe it's another member, maybe it's connecting them to the resources through papers or software programs to help them with the problem. Your job is to make sure that you connect them with resources needed to develop those skills to do their assignment. You're also responsible for communicating progress to interested parties. You need to be communicating when you're, say you're a system lead, like on the NASA ROV team, you have your sub-team leads and people below them. You're responsible for directing that flow of communication, where you can connect someone from the hardware to mech team or mech to software or software to hardware. And you are making sure that conversation is happening so that they can accomplish their individual goals for whatever task they're working on at that time. You're also responsible for resolving conflict within the team. You are the person that's going to be basically the mediator between any conflicts, whether it's between team members not getting along, that you're not having good communication going on, whatever the problem is, you are there to make sure that gets that conflict gets resolved so that we can continue with the project. And then there's more generically removing barriers to progress. As team lead, you're responsible or trying to find solutions to anything that prevents the team from completing its objective. It could be very, very big in scope and kind of crazy, kind of like COVID-19, trying to figure out how are we going to get access to machine shops to make parts, or how are we, or it could be something much more smaller, like what paperwork we need to fill out, or make sure that I can travel out of state and get vans and stuff like that. So the scope there is pretty big, something really tiny, something really big, but you're sort of there in charge to make sure those barriers get taken down as you're trying to achieve your goal. Next slide. So the three leadership types that you can sort of approach here for any problem, sort of kind of the Goldilocks. One's too hot, one's too cold, one's just right. There are traditional leaders that are much more of your standard 70s, 80s, do as I say, not as I do. Sorry, that's not words. You are given a direction, you follow that direction, and there's no questions. You as an individual have no input on the decision-making process to your leader in this case. They tell you something, you do it. While with this kind of traditional leadership role, there is definitely a goal orientation in mind where they know what they're doing and reaching there. There is no input from your team. There's no collaborative effort. So you're not getting a lot of input and not really find ways to find better solutions maybe to your problem. There's passive leaders, which are the exact opposite, where a passive leader, very hands off. Team leads and sub-team leads under a passive leader, they have free reign to do whatever they want. While that might be really great for finding a lot of solutions and getting a lot of collaboration or innovation, there's no guidance or direction. There's no one there to say, here's our goal, let's go to our goal, keep focused on it. You're starting to spread out really wide and not really get to your end goal. Then there's the facilitative leader, who's someone sort of in the middle. A facilitative leader is someone that's going to be creating more of an open environment for suggestion. They allow that collaboration, you allow for that, embracing activity, but you still provide that sense of guidance to your goal. You allow for the input from team leads and for sub-team lead team members to provide suggestions to finish your goal, to accomplish your goal, but you still make sure your team's making their deadlines. You still direct people to accomplish tasks so that you achieve your end goal. Next slide. And the last thing is sort of conflict resolution. How do I deal with the little dick? You smite them. You just smite them. You get rid of them. Nothing to it. And if necessary, one thing you want to point here is that if someone's being a jerk, you want to figure out why they're being a jerk. Obviously, if they might have problems with guidance, lack of guidance or direction. Or they're feeling ignored, not having to say. These are two pretty common problems on, say, a design team where a member may have, they don't know what to do. They may not have been given an interesting task, or they may just want to do something, but they're not quite sure how, and they're lashing out and they're just not being cooperative. So having that conversation with them and figuring out how can we reintegrate them into the team and keep them engaged so they're being cooperative and they're not being rude. Something it's a conversation you want to have. Or they may say they're feeling ignored, that they are collaborating, they're trying to collaborate, and they're throwing out ideas and stuff, but what they're saying isn't being accepted. Their suggestions aren't being taken. And this could be something like and figuring out ways how to keep incorporating the project could be something more of trying to work with them just to make sure they understand it's a collaborative process, not necessarily taking in their ideas, so their ideas might not be accepted by the whole group as a whole, because you want to have the consensus going on, but trying to find conflict resolution to bring them back into the fold and keep that and still trying to find down to why they're being rude and being uncooperative and creating conflict. Next slide. And also, if you are having problems with project leadership, one thing is we have a lot of information on the drive. We also have a lot of people on the team who've had done leadership roles in the past within the exec board and the system lead engineers and sub team leads. So if you're ever in a pit, or if you are a team lead or you're going to be a team lead and you need help, always ask. There are people out there that provide resources and that will also provide guidance and expertise on your problem.
That's the last one.
Yeah.
All right. Well, so I know that NASA is about to start our meeting a minute ago.
Yeah, Rob, you got to hop on that.
Yeah, so I guess if there are any final questions for any of us, now's probably a good time. And if not, thank you all who came. And I think we're basically good. Cool.
Okay. Well, yeah, thanks everyone for coming. Thanks for giving this presentation. And stop recording.